shouldn't, but maybe I should. It says in the diagram below, whoa. There we go. In the diagram below, AD is parallel to EF, and it is also parallel to BC. So three lines are parallel to each other. Much lovely. So we have 1, 2, 3. These are parallel to each other. So with these lines being parallel to each other, you can imagine we have quite a lot of proportionality stuff that can come out from just these three lines being parallel. They then said here, prove that AF times BD. So let's see where AF is. AF times BD. That's like this line over here. Let me use a different color for it so that it can, like, you know, stand out. There we go, BD. And then we have AC. AC is, where is AC now? AC is like here. And then where is DF? DF is like, DF is like, whoa. DF. Yo. Yeah, this question, it's obviously a bit crazy, because if a person is going to just look at these lines individually, you can imagine it's gonna be a small nightmare. But unfortunately, I mean, we have something to like refer back to here. So I think it may be a better idea to maybe just look at this and just give an answer. So what we can do is, let's see if this was not there, right? Looking at the lines that they have drawn, or the lines that were given, the only thing that they gave us was that these lines are parallel to each other, 1, 2, 3 lines. Now, from those 3 lines being given, they then speak of line BD. BD is in this triangle. And then they speak of like AC. AC is in that triangle over there. And then they spoke of AF, which is like that small line over there. And then they spoke of DF, which is this line over here. So without maybe having to have seen all this, let's see what we could have done to like try and figure out this question. So any question like this, right, is obviously going to be talking about the proportionality theorem. So the big idea would be to figure out which triangles are they actually talking about. The moment you can figure out which triangles they're dealing with, then you're safe. So always pick pairs of triangles that form a sketch like this. You see, as long as your two triangles form a sketch like this, you can work with them. You see, whether it's a sketch where the lines are, where the line is like that, or where the line is like that, it really doesn't matter. As long as you have this kind of an image, then you can pick those two triangles to like work with. So when they mention the line, let me say here, let me just make this a bit, let me get another image so that we don't get too cluttered. Let me also crop out this that they wrote out so that we don't maybe get confused. We'll refer to it maybe if we get stuck, because hey, don't want to be arrogant here. Maybe this question is like, you know, something from Mars or something, or Venus, or wherever it is that, I think you get the idea. So anyways, with the lines that they spoke of, right, the idea is you want to figure out which triangles they could possibly be talking about. So the blunt thing to do is obviously the lines here where they speak of DB. So them speaking of DB, I mean, like the one triangle that we would want to like deal with is probably this big one here. You see, that's the one triangle we would probably want to deal with. We would be thinking of that triangle. Let me actually crop this out also so that we don't get, you know, we don't cheat. So the reason why we would want to be thinking of this big triangle over here is because that's the only triangle that accommodates line DB. You see, so we want to think of this triangle. Secondly, they spoke of line AC. So, but before moving on to AC, right? The one thing we can see is that the moment they're going to talk about this big triangle over here, we may want to think to ourselves, okay, fine, we need to find a way that we can, what you may call, I mean, like for this big triangle, the only other triangle that could go with this one in terms of working with the proportionality theorem is this triangle over here, you see. So this is one set of an image that we can think of. With this image in mind, let's think of another variation based on the lines that they gave us. So looking at the lines that they gave us, right, we could also be thinking, okay, they spoke of AC. So them talking of AC, we have the long line AC over there. And then I mean the only triangle that accommodates this big line here is the triangle ACB. You see, this would be my thinking. If we bomb out, remember, luckily we have that. We can just double check what they did and be humbled. So if you're thinking of this big triangle over here, thinking of the proportionality theorem, right? The only other triangle that looks like it would work is this one over here. You see, unfortunately, us thinking of this yellow and blue triangle, the yellow triangle gives us access to line AC, the blue triangle gives us access to line AF, which is okay. Of which this image here also, right? It locally gives us access to line DF, you see. So just looking at how we have spoken about this image and this image, we can see that as long as we can deal with like the proportionality theorem with this image and deal with the proportionality theorem on this image as well, we'll be good to go. So the fortunate thing is dealing with the proportionality theorem when you have sketches that look like this, you don't have to worry about doing any proving of any similarity because of the sketch. It already tells you that the green triangle is similar to the purple one, the blue one is similar to the yellow one. So from all this being said, right, we want to see what kind of ratios we can write down that will at least have the line DF here, and that will at least also have the line AF. So that part, so that way of thinking, we just have to be a bit sober. You know, we don't want to overthink it. We just want to be calm, and we just want to write out what we can, you see. But the other thing also is sometimes we don't want to just write randomly. Like what you want to write, you obviously want to think to yourself that, okay, there has to be some form of method to the madness. So that's why here I'm also almost like stalling, because looking at this here, we can write down many things, you know, we can write down many things. But then one way we can use to help us write out what we need to write out is the question itself. You see, so let's see what the question looks like over here. Let me crop this out, do this. Let me do this. Yeah. So I just want to see what the question looks like, because if we can see what the question looks like, we can maybe try and figure out how to write out our different ratios and stuff. So here in our question, right, there is AF mentioned. Okay, fine. So there's AF mentioned over there. So I think because there's AF mentioned, right, we can label the blue triangle AFE. So we have triangle AFE, right? And then as long as we're speaking of triangle AFE, we'll have to talk about triangle ACB, because the name, the way we label the triangles, it has to like match. So this is triangle ACB, ACB. And then, so that accommodates this, that accommodates that. Here we have a DB, or a BD rather. So where we see BD here, we may want to name the purple triangle BDA, you see. So the purple triangle, we can name it BDA. And then once we have labeled the purple triangle BDA, we have no choice but to label the green triangle BFE. So there's B here, F, and E over there. You see, we have no choice. So now that we know that this is going to be similar to this, and we know that this is going to be similar to this, what we can then do individually up here and down here, we can write out our proportionality expressions based on the way we have labeled our sketches. So before we even worry about this, so looking at what we have up here, right, we can write here AF over AC, AF over AC is equal to FE over CB, is equal to FE over CB, which is also equal to AE over AB, AE over AB. And this is all written out because of the proportionality theorem. Proportionality theorem. at the bottom here, we can write a few expressions in the same way. You see, so here BD over BF, BD over BF is going to be equal to DA over FE, DA over FE, which is going to be equal to BA over BE, BA over BE. There we go. There we go. So this also, the reason would be the proportionality theorem. Proportionality theorem. So from that being said, right, now we can look at our images, or rather now we can look at our expressions, and then we can see what is it that we can like work out to like help us in this small mess that we're in here. So whether it's a small mess or not, I don't know. So the easiest thing to do is what we can try out is firstly looking at this that we have up here and looking at what we have down here. What I normally like to do is looking at what we're trying to prove, right? The first thing is here they're mentioning AF, right? So we may want to look and see where is AF in our expressions here. There's AF in the answer we want, so there's AF over here as well. So this might help us. There's BD in the answer we want, and there's a BD over there. Okay, so that's fine. There's AC in the answer we want, and there's an AC over there. Perfect. And then here there is a DF in the answer we want, and it doesn't look like there's a DF anywhere here. So that obviously is like kind of scary because it's like, wait, there's no DF anyway. So I think the DF part here is probably going to be the one that's going to maybe give us a few problems. And then the other thing is I'm looking at the picture that was sent, and we also don't have what you may call, we don't have the proportional, we don't have what's that thing? We don't have what am I saying? We don't have like a marker location. So it's also going to be a bit tricky for us to like figure out what it is that we're going to do. But then let's see. I mean, like we'll just look and see what we can do. So there's AF, there's AC, there is whatever else is over here. And then we have BD over here over BF. Where's BD? BD is over here. BF is over there. And then here we have GA over FE. And then lastly, we have BA over BE. Okay, fine. So I think for the bottom portion of things, right, we may have to create an expression that will automatically have DF in it. But the only issue now is if we're gonna have DF in there, yeah, it's gonna be a big mess. But I think with all that we've written down, let's see what it is that they wrote so that we can maybe reverse engineer what we wrote and then also better understand what they wrote. So looking at what we wrote and looking at what they wrote, let us see what we can come up with. Rope. And then what you also want to take note of is whatever you're going to do, like there's no need to be arrogant, you see. Like if it's something that's like a bit crazy, just see what you can, like see what answer they have and then move on. Because you don't want to put yourself in a position where you maybe think that absolutely everything 100% of the time always has to make sense. That's where you end up becoming stressed and depressed and sad, you see. But anyway, so here this is what they did. They were working with triangle ABD, right? So ABD, they were working with that big triangle, which is also a triangle that we mentioned. Secondly, they were working with triangle ABC. So triangle ABC is the big one here also, ABC. Now with these two triangles, right, they said here in triangle ABD, they wrote here that AB, let's just try and follow that motion. They wrote here AB over over AE is equal to BD, yes, which is the long line over here, over DF. Yes, that's correct. Fine. Because you see the motion that's happening on the top part here is the same that's happening down here. So they wrote this because of the proportionality theorem. And then the next thing that they wrote, okay. Both triangles have this portion over here. Okay, so the next thing that they wrote is that AB, right, which is still gonna be this here, over AE, which is this over there. It is equal to AC, which is gonna be this long line over there, over AF. AF, yeah, which is like this tiny part over there. Oh, okay. Okay, I think that's fine then. So with what they wrote out, I don't think we are too far out from what they have, because from what they have, right, all we need to do here is with our sketches, right, like for example, this yellow and this blue, and then this purple and this green. The one thing that they both have in common is this long line over here, the line AB. They both have access to the line AB. So what we can do is, for this, let me add this person. Give me 2 seconds, just gonna add this person, but I don't know what they're gonna gain from joining now, but it's fine. So from what we can gain, the one thing we can gain from here is they both have AE in them, right? AE and AB. So it looks as though if we're gonna end up accessing DF, right, we have to make use of AE somehow. And then if we're going to access AF, we have to make use of AE as well. So what I'm trying to say is for this pink, for this yellow and blue triangle, right? It looks as though we can write out AE as we saw the AE over AB, AE over AB is going to be equal to AF over AC. This is equal to AF over AC. The reason here is just the proportionality theorem. Proportionality theorem. So that's for this yellow and blue triangle. For the purple and green, it looks as though we may also need to accommodate AE and AB. So for the yellow and green triangle, if you say AE over AB, let's see here, AE over AB, this is equal to DF over DB. So this is like DF over DB. Let me check if this is what they also have here. Nope, don't look like it. Is it? No, DB. Here they have, what do they have there? Hi. AB and AC. Here we have AB and AC flipped over, which is fine. Here we have AE and Z, DB, DF and DB, which is fine there, fine there, fine there, fine there. And then here AC and AF. Yeah, perfect. So what we have over here, let me just try and highlight it. One, we can name this hashtag 1, and then we can name this hashtag 2. So if you look at what they wrote on the memo here, right, they said here both of them are equal to the ratio AB over AE, which is technically what we also have here. Because if you look at what we have here, right, this is AE over AB, and then down here, this is also AE over AB. So they're both equal to AE over AB. And then the thing is, looking at what we're trying to prove here, there's no AE over AB or AE or AF anyway. There's no AB anyway. There's no AE anyway. So what's best to do is to just equate this with that based on the fact that they are both equal to AE over AB. So from all that being said, right, we know that this here Just copy it so that we can take it down to the bottom. Let me paste this over there. And then this that we have up here is also equal to AE over AB. So let's just paste this over here as well. So these two, we said they're equal to the same thing, you see. So as a conclusion, according to what they did here, right, they said here, therefore DF over DB, right, is gonna be equal to AF over AC because they are both equal to the same thing. And then once that was written, all they did was to cross multiply. So cross multiplying, you're gonna have DF times AC over here, which is going to be AF times DB. AF times DB. And then if you compare that to what we were trying to prove, it looks as though that is what we have. It's more like maybe mixed around, but it's still the same lines and all that. So for example, we already can see here that there is AF and BD, of which on our side there's AF here, and this is the same as BD, it's just swapped around. And then here we have AC, and then here we have DF. So from this kind of equation, I think, I don't know which example this was from. If it was from a textbook, then that's fine. But then if this is, let's say, something that you will like bump into in an exam, I mean, the easiest thing you can do first off is to maybe just look at it after you've done everything. Because you can imagine, I mean, I think maybe now that we've done this example, right, it's going to be something you can keep in mind to say that if two sets of images have like one long line that is both in those two long triangles or whatever, then you can always make use of that to help you work out what you need to work out. Because the first thing we drew out was this yellow and blue triangle, right? It also has this long line. The next thing we drew was this purple and green triangle. It also has that long line. And then the issue was that from this long line, right, we had to make sure that we end up with specific expressions that can help us. So the normal ones clearly did not help us. So we just had to make up ones according to like our sketch. Now making up these different ratios here, right? It's all a matter of making sure that what you're doing on one side, you're doing the same on the other side. You see, that's why here for the colors, if you look at the colors, the blue here, you have small blue there, long blue there. Here you also have a small blue and a long blue. If you look at the yellow, you have the same thing. You have a small yellow there and a long yellow over there. And then on this side, you also have a small yellow there and a long yellow over there. You see? So as long as that kind of a motion is happening both on the left side and on the right side, you're able to write out the different expressions that you need for you to be able to answer the questions that they'll ask. So for this question, yeah, fortunately, I also don't think this is very examinable because, yeah, it looks like it's just going to take a lot of time. But then that's that for that question. So let me stop this recording.